So today we are going to see how to set up an SNS topic and how to subscribe to the topic. We saw how we can use SNS for sending notifications to email or a JSON format or an SMS format. So I'm going to show you how to set up a topic and subscribe to it. So you choose the SNS service using the services option here, search it, and then come to this dashboard. And here in the topics, click on that, or you can use the create topic option that was shown there. And here you can see in my screen, as of now, I have one topic already. If you remember, in some of my other Lambda discussions, we use the S3 event notification window. So I'm just going to resize it. For some reason, it doesn't work, I guess. Auto hide, apply. No, it doesn't work. Anyway, let us not focus there. So there's already one topic. We just need a new topic for monitoring in this case. So what I'm going to do is click on create new topic and give a friendly name. So I'm just going to say it is going to be server monitor and monitor my server. Okay, it says I need to have only 10 characters. So server mon. Click on create topic. Okay, you see here server monitor has been created and there is an ARN for it. So this is a topic now. So under this topic, you can have any number of subscriptions. When I say subscription, it is like the email subscription you do for newsletters or deals or offers. So this is how the subscription works. So click on this one, and or you can also go here subscriptions on the left hand side. That is also possible. You can go here and it gives me all the subscriptions that are in my account. So here, if you see, they are listed for each and every topic that are there. So this is one way you can go and create a subscription, add an email address and attach it to a topic, or go to a topic itself. Under actions, you can say that you want to create a subscription here. So you can say subscribe to topic. So it is asking me what type of protocol I want to use, whether it is HTTP, HTTPS, email JSON, or do I want to trigger Lambda for some downstream action, or do I want to send it to another application which is having an application ID, something like that. So in this demo, we are going to see how to set an email subscription. In other words, a simple email address is going to be sufficed here. So I'm just going to type one of the dummy email addresses that I use for quite a lot of things. So let us say this. So what happens is Amazon will send an email to that email address that we just now typed, and it is going to send you an email, and you need to click on that to subscribe. So I kept my email address open here, and you see here already the new mail has come. And if I go here, you see here it is AWS notification subscription confirmation. Open this email and click on confirm subscription. So once you do that, Amazon will verify that the user has also subscribed to it, so it can confidently publish information to this email address now. So that is how simple as it is to set a notification topic, and under the notification topic, you can have any number of subscriptions you want. So if you have a mobile device which can receive topics, you can go ahead and do the same thing. Only that your mobile device will need a mechanism to receive those emails or JSON messages. You will need some kind of processing system to receive those images. In terms of email, Gmail knows how to receive an email and put it into a mailbox. So now that we have done a notification topic and we have subscribed to it, so what we are going to do is we are going to head over to CloudWatch and set a monitoring agent. So it will monitor the web server that I have here. Say here the monitoring demo server. It is going to monitor the server for a CPU metric and what is the metric, like whether the server is up and running or not. So if I go to my monitoring tab here, you see a lot of metrics happening here. The CPU utilization, you see a small spike here, how many disk writes. So we are going to set a monitoring alarm for this server now. So since it is up and running, we don't have to make any changes here, just leave it as it is. Let me just copy the instance ID so that we can quickly go ahead and configure our CloudWatch alarm for that. So go to CloudWatch. Once again, for going to CloudWatch, all you have to do is services, search for CloudWatch, and it will take you to the dashboard that you are seeing here. And under the dashboard, click on Alarm and click on Create an Alarm. So under Alarm, a lot of services are supported here. As you can see here, if we just close this one, probably in the dashboard it shows, I think, it supports about quite a lot of metrics. I don't remember the exact number. There we go. Yeah, here it is. Your CloudWatch metrics has been loaded, and there are total metrics of 788. So you can choose any of these metrics to monitor your particular service of interest. So when it comes to EC2, there are about 378 metrics for you to pick and choose of what you want to monitor. So let me just go ahead and click on EC2 just to give you an example of the metrics available. And it picks up all the previous instances and all the different metrics that you can choose for that instance. So this is why I said we'll copy the instance ID. So I'm just going to copy paste that instance ID. It takes a while for all the other metrics to come on. Like for example, network packets, network in, out might not be visible immediately. It will take some time for the CloudWatch to collect it, collate it, and show it here. By default, you will see at least 2 metrics immediately. That is good. We are able to see quite a lot of them, 14 of them. Good. You can see here the CPU credit balance, credit usage and utilization, and the status check failed. That is whether the system hypervisor level is good. That is the system's check. And the instance level, whether the virtual machine is receiving traffic and performing the function it is supposed to perform. So these are all the metrics available to you for this particular instant. And if you go to auto scaling, once again, you will have different kind of metrics. In this instance ID, we don't have auto scaling, so that is why it is not showing. So, but once I remove that, you see here all the other metrics that are relevant are shown here. So let me remove this filter and just put the instance ID back. And for our demo, we are going to choose CPU utilization so that we can stress the server and find out whether the alarm is triggered or not. So the name of my alarm, CPU monitor, that is what I'm going to call it, CPU monitor. And here in this case, on the right hand side, you see here what is the period I want to monitor. I'm going to say monitor a period for 1 minute. So duration, every 1 minute is going to monitor it. And if the average CPU is greater than or equal to, let us say, 40%, and consecutively for 1 period, let me make it as let us say 3 periods. So consecutively for 3 minutes, if my CPU is going to be, can I increase it to 2? No, I cannot. So if it is consecutively more than 40% for 3 minutes, I should be getting an alarm. So how do I get an alarm? You come down to actions, and here you see here, whenever this alarm is triggered, what is the state you want it to be? Whether state is alarm or OK or insufficient data. So I want an alarm to be triggered. So I'm going to choose state is alarm. And where do I want to send my notification to? Here is where the SNS topic is coming into picture. So I'm going to select the one that we just now created. Let me see. Oh, it is not visible. Okay, what I'm going to do is I'm just going to refresh the screen. Sometimes the CloudWatch does that. It doesn't pick up the latest SNS topics. So let me just refresh my screen and quickly head over to my instance ID, CPU utilization. Click on next. CPU mon. Meanwhile, yeah, there we go. My server monitor is appearing here. Server monitor, if it is more than 40% for consecutively 3 minutes, set my period to say 1 minute. And you see here automatically when I choose server monitor, the email address list is getting updated automatically. You don't have to do anything. And if it is an auto scaling is configured, you can click on auto scaling here, and you can see here which auto scaling group that you want to take into effect. As of now, there are no groups. And whether you want to scale in or scale out action, what is the auto scaling thing that you need to do here? So you can remember when I spoke about the EC2 recovery action also, that it is possible to recover a server or stop a server or reboot a server in case an alarm is triggered. And remember, this will work only if you're using certain C type or M type or R type instance, not on a T2 micro. So for a simple quick demo, let us use this configuration. Go ahead and click on create alarm. So initially it is going to collect some data for some time. If it is already having a data for 3 minutes or 5 minutes, you can immediately see it as okay. Otherwise, you might see it as insufficient data. I mean, whenever the alarm state is insufficient, that means that CloudWatch doesn't have enough data to compute whether the alarm should be triggered or not. In this case, I'm just asking it to look for a 3-minute window, and it is saying that it has enough data to make that decision. Let me see if I can pull this little bit more this side. The graph wouldn't come because my screen is a little messed up. Okay, let's just move it this way. So let me go back to alarms, and you see here there's this very small tiny spike on my graph. That means that my CPU is nowhere close to 40% and everything is fine. So this is one way you can create an alarm. There is another thing that you can also do. You can create an events also, and based on certain rules an event can be triggered. Say for example your status of the server is changed from running to stopped or terminate. When that kind of an event happens, you want to get notified. So you can do the same thing using this option. This is quite powerful in terms of S3 notification, or starting a server at a particular time. Say for example every day morning you want to start a server at 6 o'clock and shut it down at evening 10 o'clock. So you want to have a cron job or a scheduled event happening. So this is where you come and do that. Click on create rule, and here you see two options that you have: event pattern or schedule. If I choose schedule, automatically it will give me ask me a cron expression how I want to do it. If you are not sure how to set this up, go ahead and read this learn more bit. It gives you a lot of options of how to write this up properly. So in our demo now we are going to choose an event pattern, and let us choose a service name here as EC2 because we have a server running on EC2. And what type of events? I want all types of events, whether the EC2 status changed or anything happening in my EC2, I want it. So all events that are happening in EC2. So where do I want to send the target, or where do I want to send the notification to? So click on add target, and here once again you see here whether it's an SNS topic, SQS, or some other command that you want to run, or Lambda function you want to invoke. All these options are available to you. So quite often people do Lambda and SQS here, or directly call other services also. In our example, we will use SNS, choose server monitor again, and automatically the input will be matched here, and that is all we have to do here. Click on configure details, and that is you see here at the bottom, and what is the rule name that you want to say. So EC2 event notifier, that is what I'm going to call my event. So and the state is enabled. So by default, if you check this, not by default, if you check this, this event will come live immediately. So as of now, I'm not doing anything in EC2, so there won't be any emails in my subscription or in my email address. So let me delete this as well. So if something happens, we'll get the notification there. So let me go back to CloudWatch. You can see here the alarm keeps on checking itself, and if it finds for some reason something has gone wrong, the status keeps changing here. CloudWatch is still working on the amount of data that needs whether to trigger an alert or not. So if we want to trigger this alert, what I'm going to do is I'm going to go to my console and stress the server so that we can spike the CPU to 100%. So I'm just going to copy over this command to my server here. So the 400 seconds is about more than 5 minutes. So we should be definitely triggering about one alert or alarm at least. So let me start this. And if I go over to my top command performance monitoring, you can see here the CPU has immediately spiked to 100%. So it is going to take at least 3 minutes for the spike to show on CloudWatch dashboard and trigger an alarm email to us. You can see here there is an alert notification in my email, and the alarm has been triggered from my CPU monitor. So it says that you are receiving this alarm because there is a CPU spike, and that is the reason C was greater than or equal to 40%, and from insufficient it went to alarm. And if I actually go back when I was speaking this, it went back to insufficient data stage because the CPU spike has subsided and it is gone. It is no longer in the alarm condition, so it is still collecting data to see whether it is in the OK state. So it is going to wait for another 3 to 5 minutes, and then it is going to put back into the OK state. So if I go to the EC2 dashboard itself and go to the monitoring view, I should be able to see a CPU spike in the utilization part of it. Where is my CPU here? This is the burst balance. This is not my CPU utilization itself. If not in the CloudWatch itself, I should be able to see it. Let me just go to my CloudWatch alarm. Yeah, if I click on this, and if I can ask it to break it down to 1 minute, you can see here there is a spike for spanning about 1515 to 1520 at a CPU of about 60%, close to that. So that is why my alarm has been triggered, and then I got an email as well. So typically what you can do is you can forward this to a downstream system like a Logic Monitor or a ServiceNow, IBM Tivoli, or anything that you are comfortable with, and create an auto ticketing system. So this is how a CloudWatch monitoring system works. I'm going to demonstrate how the rule that we configured in CloudWatch for an event-based monitoring works. So this happens only when there is a state change. As of now, my server is running, and that is why nothing is happening. No alert has been triggered. So what I'm going to do is I'm just going to turn this server off. That is, in other words, I'm going to stop the server. Instant state. Click on stop. Okay, there we go. You see here the CPU utilization here. Earlier I was in the volumes. Now when the CPU, so the CPU utilization is here. If I can, no, I cannot narrow it down even more, but I can zoom in. You can see here the CPU spike went about to 60% here. So this is what the spike that we just now created for some time back. Let me go and turn the state into stopped state. As of now it is running. Let's go ahead and click on stop. And if you remember, this one was earlier there, we skipped it when we were looking at EC2. So if you want to create an alarm for your server, you can do it from your EC2 dashboard screen also. So in this option, it will say usually create an alarm. So if you click on that, it will take you to the same CloudWatch dashboard that we used some time back. So as of now, it is saying that is one alarm, and that has been triggered. So anyway, if I go to my emails, now it's already triggered for a notification of CPU monitor. That is, I'm still receiving an alarm for CPU that is at 8:58, and which says that it is equal to 40%. And I have received one more notification which is in JSON format, and which says that the state is stopping, and that was received at 9 p.m. And you see here at 9 p.m. again the state has changed to stopped. So any change of state, I will get an email. So if I'm going to again go ahead and trigger start or restart the server, when stop change to starting, and then starting changes to running, I will get 2 more emails now. So let's go ahead and try that as well. Since the server is stopped, now I'm just going to click on it and start again. So since the state changes, SNS should pick up this pending state, and then it will send an email. You see here already one email has come. If I go ahead and open it, and you can see here the state is pending now. So if we wait for some time, this pending will change into a running in a short while. So okay, it is running, and SNS should pick that up anytime. And we should be able to see an email soon, or it might have already arrived by the time we came here. So I'm just going to go ahead and refresh it. Yeah, there we go, the mail has arrived. So if I go to SNS, and you can see here the state has changed to running. So this is how an event-based notification or a triggering for EC2 can be done in AWS. Now we are in the SES service, and we are in Virginia since SES is not available in all the regions. The first thing that you need to do is you need to register the email address to which you want to send emails. So what you do is typically you go and verify an email address. In other words, just like we did for SNS topic, we need to subscribe or we need to verify every email address that to which you want to send an email. So typically that is very simple as you're doing abc at example.com. By the way, example.com is globally agreed as a sample domain which you can use it for demo purpose or testing purpose. So if you want to do something like this, click on verify email address. The third party will be getting an email. Once they click on that, that email address will be approved. So you see here, you successfully sent a verification email. It may take up an hour for a verification email to arrive at the user's inbox, blah, blah, blah. And you can see here that is a pending verification, and if you want to resend it, you can resend it also for this email address. So only when an email address is approved, you will be able to send email using SES service. So in my case, I already have one of my dummy email addresses set up, and we are going to use that to send an email. So let me remove this guy. I don't want any spam people to send emails from this. So if I want to send a test email, or what typically happens is people use this SES service through a programmatic email service. They don't use it from the dashboard to send millions of emails. They access this service through their applications or mobile apps and use this service to send emails to all the endpoints. As you can see here on the left hand side, you have email templates. You can configure your email template and let us say hello user ABC. The ABC will be filled in by the app itself or the application that is using for the username, and the content will be more or less the same, especially promotion messages. The content except the username, everything is the same. So you can create a template and send it. So that is how some of these settings are working. Just go ahead and play around with it. Very simple and straightforward. If you have a domain name through which you want to send a particular email, say like we did mywebsite.com, and you want the emails to appear as if it is coming from mywebsite.com, you once again verify your domain. You type in your domain name. Amazon will generate the DKIM keys, or as it says, domain key identified mail. In other words, they are going to verify you are the owner of this domain name, and you are going to be allowed to send identified emails. So because if you're going to send a lot of spam emails, in other words, if your users or end users or people who are receiving it are going to mark it as spam, Amazon is going to write an email and just block your domain name from sending any more emails. They are very particular about it. So, and there is a limit is also there in the service. Like for example, every second you can send only X amount of emails. And there is a per day limit also is there, so that you don't misuse the service and start firing emails at everybody. So having said that, I'm just going to quickly trigger and send a test email. So I'm going to say this is my from address and this is also my true address. I'm going to say, okay, this doesn't work. Okay. So does anybody want to share their email address and let me know whether they are receiving it? Can they quickly share it in my chat window? I can just put a comma and try it out. Mostly it wouldn't work. Nobody? Okay, click on send test email. And this number should change to 1 or 2. No, this is on particular topic. I don't think so it will change. But meanwhile, let us go ahead and check the SNS notification for terminated state. So if I open this, the state should be terminated here. Yep, as you go here. So let me open my inbox and see what is the state, whether I have got the email from SES itself. You can see here there is a test email from SES and we have received it in our inbox. And if I just expand it, you can see here the domain name is something like amazonses.com. So if you don't want it to be showing up as Amazon SES, then add your domain name here so that you can send emails as if it is appearing from your domain name. So that is how Amazon SES is used by third-party people to set up your emails. And once again, you can set up some rules like saying whether you want to say the email is coming from this address, rejected, or certain addresses you should not be sending it. So you can create some filters here. Based on that, your emails can be sent here. And there are a lot of rules that also can be set, like saying what happens if a bounce back is happening. Do I want to resend it? Do I want to create a track of bounce back messages? And things like that. So all those things are possible here. So here is a reputation dashboard. It's nothing but whether your account is good enough or not, whether you are spamming people or not. This is an Amazon view of things. It takes a feedback of all the messages it has been sent and creates this status. So if this is not going to be, it's going to be unhealthy, you are not allowed to send more emails. So make sure that you maintain a healthy status so that you can use this service for professional reasons. So we are going to see what is Amazon RDS and what it means by that, how you can use that in your own architectures when you're talking to clients, and what are the things that make up them, and finally a demo of RDS itself. When we are talking about RDS, this forms a part of the database as a service provided by Amazon. And there are multiple options provided to you by Amazon when we're talking about databases itself. So in this session or in the next few minutes, we are going to spend our time on RDS of all the other things. It is the relational database service as it is fully known. And the other common or most popular ones are provided by Amazon is DynamoDB and Elastic Cache. So what is RDS? RDS is a sequential or relational database in the cloud, and it is a managed database. What I mean by that is almost all the administrative task is managed by Amazon, like installing an RDS, setting up a cluster, and updating it, upgrading it, taking a snapshot, and making sure encryption is available and performance is maintained. All these kind of tasks are managed by Amazon itself, so you don't have to spend time configuring it and managing it. That is what a managed database means. So typically you can think of it like Amazon is sitting behind you and doing all this migration of your disks and partitioning it and ensuring the availability part of it is there, resilience part of it is there. So when you're talking about RDS, there are multiple features that you want to know. So it is a very simple to use. Almost it takes about 5 to 10 minutes only to set up an RDS, and it might take more time to come online, but it is one of the most easiest database systems that I have encountered to set up. And it is comparatively cost effective when you're trying to set it up with or compare it with an on-premise database systems for the functionality it provides. And in terms of security, you have the encryption part of it, you have it in a VPC, and you can have IAM roles so that you can have only certain people accessing RDS itself. So predictable performance, just like an EBS volume, you can trigger the performance of your RDS also. You can say this is the IOPS I want an SSD disk, and you can ensure the performance is throughout the same. And it is going to scale to demand. What is means that is the number of connections as it scales up, your RDS database is also going to scale up. If you are struggling for more IOPS, then all you have to do is to go to your RDS PIOPS and increase it so that more connections or read-write activities can happen. And RDS, once again, the snapshots are stored in your S3 bucket whenever the snapshot is taken. So typically they are very durable, and you can connect to RDS typically because it's a DNS name, just like CloudFront or ELB. For RDS, you will get an endpoint which is a DNS name, a routable DNS name. So you can, it is compatible with a lot of your applications. And finally, as I said some time back, the administrative tasks is comparatively less when you compare to an on-premise database. And the number of engines supported here is quite vast. You can have MySQL engine. These are different databases available in the market. MySQL, which is MariaDB, is another variant of MySQL. This is owned by Oracle, and this is owned by the open group, not the open group, Apache group. And Postgres, Microsoft SQL Server, and Amazon has taken MariaDB and MySQL and improved it and called it as Amazon Aurora. This engine is fully compatible with the MySQL. So you can take a MySQL database and migrate it to Amazon Aurora also without any problems. As I said, they have taken it and improved it, and it's a completely different database, but it is fully binary compatible with anything that is stored in MySQL. And finally, most importantly, you can run the giant Oracle also inside RDS. So that is also possible to run it in the cloud without any management issues. And when you're talking about RDS instances, the instances make up the building blocks. So they are typically kind of like your EC2 boxes, but only the difference is instead of having T2 RR or M series, you will have something like db2.micro. I mean, not db2, db.micro, db.nano, db.large, x large, 4x large. So they are basically DB instances, and you can create multiple databases inside a single instance. So it is not like 1:1 mapping. You create a DB instance, you can have multiple databases inside that one instance. And each of those instances are isolated and they are all in the cloud. There is no on-premise or some things like that. And if you are setting up in a high availability configuration, which we'll see in a short while, the read snapshot is created automatically for you. We'll see that in a short while. So that is what about the DB instances about. If you're talking about security, you can run your RDS inside your VPC. So when you're choosing your RDS, it will ask you under which VPC you want, what security group you want, whether you want encryption, whether you want a SSL connection, or you want to use the database own features for security also. That is also possible. Say, for example, Oracle is coming up with some security features, and Amazon has an option called parameter groups. Using that, you can secure your database also. So there are multiple ways to secure your database in the cloud. Moving forward, how does the backup or automatic management works? Just like in your on-premise world, there are two options for you. One is automatic backups, just like the cron jobs or scheduled jobs we saw some time back when you're doing CloudWatch. You can create a scheduled snapshot backup for your RDS also. And it also gives you an option to see, say that whether you want the database to be temporarily paused so that you can take a backup without any issues. In other words, it's a minor downtime and it allows you to choose how much downtime you want. And you can have a retention period of up to 35 days. If you want more, you can have a snapshot and replicate it across the region and then store it in your S3 bucket as long as you want it. The default period is about 35 days. And having said that, you can also do the manual snapshots. So there is nothing stopping you. Instead of having every day at 8 o'clock, you suddenly think that I have made a lot of changes at 2 o'clock and you want to take a copy of the snapshot, go ahead and create it manually, and that is also allowed. And the interesting thing is the manual created snapshots are not deleted automatically. Where in automatic backups, any snapshot folder is deleted automatically after the set period of time. So manual snapshots stay as long as you need it. And so you need to go ahead and manually clean up your snapshots account. But typically in a production, if you are taking a snapshot, you most probably need it and you will only delete it after making the necessary checks. So that is the reason Amazon doesn't clean them automatically. So there is something called cross-region snapshots is possible. That means that if you want to have a disaster recovery scenarios or for compliance reasons, you want to move the data across regions, you can trigger this also in your account. So you initiate that snapshot, in this case as shown in the image, Virginia region it is running, and you can trigger a snapshot to say Tokyo or a Brazil region. And this provides a very good disaster recovery option. And remember that this is not asynchronous, it is asynchronous. So there is going to be a small time lag, or the commit of data is going to be different from the source. So although it is going to be a good disaster recovery, but not a real-time recovery solution, there is going to be a small amount of data loss if you are going to propose this as a typical backup and recovery solution. So ideally what you do is you do this and also take in commit logs or roll logs or archive logs, as in DB2 it is called, and constantly take a snapshot of that in the EBS volume and push it to other regions for a full disaster recovery solution. So there are two more things that we need to know when you're talking about RDS. One is parameter groups and another is option groups. So when you're talking about parameter groups, every database engine, whether it is MySQL or Oracle, comes with a lot of parameters to fine tune it or customize it to make it suit for your requirements. One of the best examples is time zones. If you are in an Indian region, all over the country we have using IST. But if you are in Europe or in the North America region, there are multiple time zones involved. So if or to ensure that transactions are happening at consistently across multiple time zones, you want to customize your database for that particular region or set it at UTC time, whichever way you want it. So these kind of customization parameters are can be done in your DB parameter group. Amazon has a default parameter group. If you are not sure how to use that, if you start a database engine, by default, the default parameter group will be applied. If you want to customize it, then go ahead and create your own and apply your parameters on top of it and then use that. Likewise, Amazon has something called DB option groups, which is nothing but customizing the management activities. When you want to take a backup, when you want downtime to be done, when the minor upgrade to be done. So all those things can be customized using the DB option groups. So if I show you a simple RDS architecture, which is not highly available, this is how it looks like. There is two EC2 servers in the middle, and there is a load balancer at the top, and they are talking to a single master instance. In this case, there is no multi-AC standby. It is written as multi-AC standby, but there is no multi-AC standby here. Meaning, if this master goes offline, your data is not available. So it is not a fault tolerant or high available configuration. So if you want a high available configuration, you need to use an option called multi-AC deployments. What it means is, once you create an RDS instance, the master copy is put in one availability zone, and there is a standby replica created in another availability zone, and data is copied synchronously in this case. So that is the difference between cross-region snapshots and using a multi-AC. In multi-AC, everything is synchronous. So for some reason, the master goes offline. The standby replica is promoted as a master, and automatically the traffic will be shifted to the standby, so that your applications will not see any downtime at all, and you will not have any data loss also if one AC goes offline. So this is how a multi-AC deployment for RDS happens. And this there is an additional cost associated with multi-AC, but production typically goes with the multi-AC deployments. So in architectural wise, this is how it is going to look like. There is a load balancer, which is talking to 4 different EC2 instances, and those instances are going to talk to only your master database. You cannot talk to your standby directly. Amazon only can talk to it. Only if something goes wrong with your master, the standby is promoted to master, and once again you will be talking to your master server. So that is how you design a resilient and durable database for your applications. So that is how a relational database looks like in the cloud. So when we compare relational to another database systems that is available in the market, there is something called NoSQL databases. So when you are talking about NoSQL databases, DynamoDB is Amazon variant of NoSQL databases. There are other things like MongoDB, Cassandra, HBase, so many CouchDB, so many things are there. The best kind of use cases to understand is think of images that we all take. A person like me will take more images, a person like you might take less images or more than me, and each of us will have every day clicking thousands of hundreds and thousands of images. So somebody has to store this image. Let us say all of us are uploading it to Facebook and Instagram, and Facebook sends this as a feed message to other people, and the likes, the comments for each of those images has to be stored separately. So in this way, the complexity increases. For each person, there are hundreds of images, and for hundreds of images, I'm going to track X number of comments, likes, and reposts and feed items. So writing this all into a sequential or a relational database is not going to be very efficient. That is where you come up with systems like a NoSQL database, where the things are stored as collections rather than a relationship between the first record and the second record. So DynamoDB is a very good example for this use case. I'll just go ahead and show you some examples or representational view of how data is stored, and probably that you will be able to more correlate how a DynamoDB or a NoSQL database looks like. But before doing that, a couple of words about DynamoDB itself. It is once again a managed database. There is no dial for performance. Amazon gives you a read and write metric. How many units of read write you want? For example, read is about 4 KB per unit and write is about 1 KB. So you go to Amazon and say these many read units I need and these many write units I need, and Amazon will ensure that much performance will be always met for you. And remember that most all the data is stored under SSD disks. So performance is really very high. The cost is also high. I wouldn't say it is the cost effective, but if you want a very high performant database and a very low latency, think of the image upload example that we spoke about. There is no question of people are not going to wait for images to be coming up on your screen and to comment on them or like them. People want to click on the like button and move on to the next image. So they want to have a database which is really high performant. And this is all small transactions. When you click on the like button, you're probably sending about a few kilobytes of, not even kilobytes, few bytes of data to the server. So for that, you don't need a transaction database like a SQL database. DynamoDB or any NoSQL database works fantastically well. That is one of the reasons Facebook invented Cassandra DB to store column-wise data or NoSQL data. So to have a quick comparison here, this is how the side-by-side comparison of SQL and NoSQL looks like. In the SQL, the data is stored in this way, that is rows and columns, but whereas in NoSQL, it is key and value. What I mean by key and value is, quickly let us see the example at the bottom of the screen. In SQL, this is a table for books, and there are multiple columns like identifier for the book, the title of the book, and who is the author of the book, and what is the format, whether it is hard copy, soft copy, things like that. If I want to store the same data into a NoSQL format, I will create one file or a collection like this for each book. This whole entry can be in a CSV file or a JSON file, or each of them is a separate file. So my identifier, in other words ISBN, is my key, and this number that is shown here is my value. So I have a key as title and a value as the title of the book. So that is how NoSQL stores your data, key and value pairs. And here the structure in SQL is standard ISBN, title, author, and format. If you want to change it, and you're going to add another column here, and all the values for all the rows will have to be updated, or you are going to say that that column is not mandatory, so you can have null values. So it is the impact is across all the rows. But when it comes to NoSQL, there is no necessity of saying the schema. In other words, the schema can be dynamic. For one book, I will have 10 key values. Another book, I will have only 4 key values. So that is the flexibility DynamoDB or NoSQL format gives you. Finally, when you are coming up querying, that is where the difference comes up with. It uses an SQL syntax, select star from tables. That is how an SQL syntax will look like. In this case, select ISBN where title equal to cloud star. So then you will pick up this ISBN value. So that is how you will do querying. But here the querying is based on collections. You will say, find me a file where ISBN value equal to this, and it is going to search a lot of files and then find the exact one. You can create an index, but it is not going to be the very efficient way of sometimes searching. So if you have combination of multiple searches like join searches, say for example, I want ISBN and title and author, I want a combination of all three. SQL is performant more than NoSQL in this case. So sometimes I've seen questions based on that, or clients asking me, what if I have join queries? What if I have very complex queries? Should I go with the NoSQL or SQL? So if you have very complex queries, you see whether SQL will benefit for that client, or if there is a re-architecting or application itself is changing, and if the application data can suit NoSQL, then go ahead and recommend NoSQL. And scalability part, since there is a relationship between the first record and then the second record and third record, it can only scale vertically. What it means is you can add the CPU, you can add the memory, and keep on adding it in the vertical database itself. You cannot duplicate the database just like that. Whereas horizontally means these are all stored as separate files. All these collections are separate files. There is no relationship between one JSON file or one object and next object. So you can immediately start another server and start storing your collections there, and you just index them or don't index them. So scalability is very high in NoSQL, whereas scalability is a big constraint in SQL-based databases. So that is one thing you need to know. And what are the use cases? Where do people use that? So this is a quick snapshot of use cases, and we have discussed this before, but quickly to summarize, if you have an existing database apps or business critical process centric process where there is a flow, where there is an sequence of actions happening, then ideally relational database will make a lot of difference here. But if you don't know how many writes are going to happen, how many reads are going to happen at any point of time, and your application is distributed across the web, then NoSQL will be a fantastic use case. So as I said, typically small read writes and faster read writes than NoSQL. And if you want transactional or complex queries, once again SQL database. But if you don't have transactional small queries, but you have range queries like what was the photos I uploaded for the last 1 year, just a simple query of my user ID, but all the images has to be picked up. And I'm not going to update much in all the items at the same time, then this kind of a database makes sense for you. And scaling wise, we spoke about this. If you want to scale this, you need to do a clustering, you can do a partitioning. These are database concepts. In other words, partitioning based on horizontal saying records for the last 1 year is stored in a different database, and the new records for next year is stored in another database. That way you can call it as horizontal scaling, but there will be still a link between last year and this year. So that is what partitioning means, and sharding is a more of a horizontal concept, vertical concept. I would highly recommend you guys to go ahead and see what is partitioning and sharding if you're not familiar with that. But in this case, it is seamless. What it means is you can just start another server and start storing your collections on your new server, because there is no linkage between the first data and the second data or the collection of the objects. So it just keeps on scaling as much as you need it. Performance is going to be depend upon how you architect it, the quality of service, in other words. So if you're talking about DynamoDB, it is automatically optimized. That means the performance is a simple parameter of how many reads you want, how many writes you want, and you can directly get that kind of performance. But in this case, the type of query that you are running, the kind of database table that you have created, how many columns are there, so many things comes into the picture to achieve the performance that you require for your applications. So that is another way to see RDS against DynamoDB. So in this page, the only thing that you need to remember is read is about 4 KBs and write is about 1 KB. So that is how your DynamoDB performance is met in Amazon. So your cost is also associated with how many reads and writes you need. So provision them as required by your client. So quickly, I'm going to show you a data model or how the data is stored. Here there is a collection of songs. Think of each and every row here, or the 4 blocks that you see here. Each of them is an individual collection. They are not at all linked. So, but it is shown as a table or a music. Let us say this is collection number 1, collection number 2, collection number 3, collection number 4, and then blah blah blah. And if you see here, collection number 1 has all the parameters: artist, song title, album, and year. And whereas when it comes to the third collection, you have another field called the genre is also there. But in the collection number 2, you have only 2 or 3 items. So this is possible to store data in this way. That is the flexibility of a NoSQL database, and each item can have any number of attributes, key value pairs, and however you want it. So sometimes for better performance, what people do is they create an index key, or another way partition key. In this case, the artist name. Say for example, pick up all the music files, albums that Mr. A.R. Rahman has done. Then you can easily sort by that or the artist name and give all the files. And it is also sometimes efficient to give a sort key also. So because Mr. Rahman must have done 10,000 songs and you want to sort them by title, then you can go ahead and sort them by this particular title of the album itself. So if that is also not efficient, you can also go ahead and create a secondary partition key also is possible. So you can go ahead and identify a local secondary index. Album title is also possible, or year, whichever you want. Sometimes it is not mandatory to have that. So these are all just to improve the performance of your DynamoDB data model. So if I want to show it as an architecture level, this is how it looks like. You have multiple endpoints, whether it is mobile or a tablet or desktop, connecting to your load balancer, which in turn talks to your application, and which on the background talks to your Elastic, the DynamoDB itself. So that is how you set up your DynamoDB based on your customer applications.